SaneSmart sent me this Creality Ender 5 Max 3D printer to put together and test out, so that's exactly what I'm going to do. And you might be wondering why a woodworker would need a 3D printer, and the answer is, well, you generally don't. But like any other tool, a 3D printer has its uses in the shop, especially for making jigs and fixtures that would be hard or impossible to make with traditional methods. But this thing is complicated, and a once over on the instructions is a must before fully unboxing. Now, I was really impressed with the packaging. There was tons of foam and nothing's damaged, which is a huge plus, especially since this thing is big and heavy. My first step was to lay out all the parts to get organized, and this printer has tons of pieces, including some lotion in case your hands get dry from all those screw turning. Oh wait, that's not lotion. Anyway, the parts are clearly labeled and pretty easy to put together. The first step is to get the frame assembled, which is nice because the aluminum rails are all referenced, so they slip right into the holes and don't require any aligning. Just put them in place and tighten down the screws. The sides also had these reference nubs on them, so they were really easy to align. Now, these parts are the parts that track the printer up and down. The only tricky part, well, not really tricky, but something you don't want to forget is the top plate. It has some set screws and they need to be loosened so the plate can slide up and sit tight to the top when you put those screws in. Next up is the printer bed, which is not this. This is the power supply that's underneath. And you have to take off this cover so you can plug in the print surface and then secure those wires in place so they don't accidentally get pulled out and damaged or something like that. And just like the other pieces, the print surface goes on and in place nice and easily and is secured with more screws. And let me tell you, I thought the amount of screws was a little overkill on this thing. There are tons, but after seeing it in action, I get why they're necessary. When in motion, this thing is aggressive. The whole body of the printer shakes, and it doesn't help that the printer is fast. Well, it's jarringly fast when you first start, but it makes sense and it's nice to be able to print faster. But anyway, everything shakes. Make sure you tighten all the screws down nicely. At this point, we've started the cable plug-in portion of the project. That's putting in this piece, which controls the actual printer head, and make sure that you get in that little white thing too. That's the tube that the filament will go through. From there, the rest of them are pretty self-explanatory. There's one here that's for the screen. That one goes straight up top. You put the little mount in place and the screen just slips on in some keyholes, easy peasy. Now, there are two wires that are a little bit hidden. These are underneath the printer, so don't miss them. You want to plug in those because those are the motors, and without them, the bed won't go up and down. The rest of the wires are really easy to identify and understand where they need to go, but those two underneath the bed, I missed them at first, which led to a tech support ticket because, well, the printer wasn't working. SaneSmart was super helpful and gave me clear instructions for what to check for based on the error code I was getting, and I quickly realized what the problem was and, well, plugged it in and it began to work. The very first time you turn on the printer, it's going to want to check its components to make sure that they're all working. Oh wait, let's pause. Ah, yes, much better. Okay, so what I was saying is the first time you turn it on, it's going to want to do a diagnostic check to make sure everything is working. This does take a while. It was like 15 to 20 minutes to go through this whole process because it has to heat everything up and move around and make sure it all is functioning properly. Once that's done, SaneSmart is very nice and they sent a little thumb drive with a print already on it. So you just plug that bad boy in, and then you want to click the button to calibrate the machine when you do the first print. That way it can check itself and make sure it's all in the right position and whatnot, which does take a long time. But of course, you need to make sure there's filament in the machine before you start. So I'm going to go ahead and thread that through the pipe, and then we'll try our first print. So here's a quick look at the calibration process. It pinpoints itself all the way across the bed and along it and does its little thing. Takes a little bit, but once it's done, you don't have to do it again. And then it starts printing. Well, it should start printing, but it's not printing. there it goes. There's a little bit of filament coming out. But I have a feeling that we messed up on the first one. Yeah, there it goes. All right, here is another print, and this one looks way more promising. So stick around. I'm going to talk a little bit about what happened on that first one, why it happened, and how you can prevent it from happening to you. After a few failed prints, I figured out what the problem was, and it didn't really have to do with the printer, it had to do with the filament and the spool itself. What happened was, as it was trying to unwind itself, it would be crossed over and it would catch and it would stop feeding the filament into the printer and cause these to eventually fail. So that happened on all of these different prints until I was able to just figure out the problem, unspool enough of the filament, re-spool it back on there, and then monitor it to make sure that there was no catching in the middle of a print. And then it started working really flawlessly, pretty much plug and play. Now, the big question that you may be wondering is, why does a woodworker need one of these? And I kind of answered that at the beginning. You don't really, but you know what it's nice for? For things like this. So my previous connection to my sander from my dust collector was just using the hose itself and a hose clamp. And that worked, but not very well. It would still slip off all the time. It was a little bit clunky. It was hard to change out. Not really the best solution. This, super easy to do. It has these little teeth on the inside that lock onto the Festool dust collector hose, and it is perfectly sized for the 20mm dust port on this Makita sander. I've used this now for a couple of projects. It has had no slipping, no issues, been super great. So if you want one of these, then, well, you can find it online and you can go ahead and print one of these yourself if you already have a printer. If you don't, then you can purchase one off of my website. There's a link down below. And that's the really nice thing about these 3D printers. You can find so much stuff online. You can print it yourself. You can just use it in your shop for all sorts of different fixtures. And that's what I'm planning on using it for. For all those tasks that are a little bit tiresome or annoying to do, they take a long time, and I don't like to do it, well, I can print out my own jigs, make that a little bit easier, a little bit faster, and I'm going to be testing some of those things out and offering them to you in the near future. So make sure to stay tuned for those. But for now, a big thank you to SaneSmart who sent me that Creality Ender 5 Max. If you are interested in that model, check the links below in the description. There will be everything to SaneSmart's website. They were super helpful on their customer support as well, so big plus there. Check that out. And otherwise, this video is done. Hope you enjoyed it, and I'll see you in the next one.